All right, so what we're going to be doing now is we are going to be working on worksheet 4, number 5. So when you look at this problem, what I note is that I'm going to start at -7, and I am going, which is down here, and I'm going all the way up to 22 degrees. So what I want to think about with these problems is I want to make sure that I think about when are any phase changes occurring. And because I'm told that it's ice, I know by memorization that ice melts at 0 degrees and starts to boil at 100 degrees. So when I go from -7 to 22, at some point I'm going to pass through 0. So I know that there is going to be one flat line in between. There is no other flat line because you do not reach 100 degrees. So my graph would look something like that, and that's 0. All right, so when I look at this, I now know that there are going to be 3 different equations that I am going to need to put together. And the first one I'm going to deal with is when you are heating up ice. And so that's going to be that section. So when I am heating up ice, okay, I'm going to be warming, and that I am going to be warming it up, and that's going to go from -7 all the way to 0. So when I am changing my temperature, I am going to be using my MCAT formula. Okay, so according to this, my mass is 235 grams. The C I'm going to use because it is a solid at this stage. This is where it is a solid because it is ice just heating up. I know that my solid one, according to my, I guess I should use units. My solid, according to my constants, is 2.11. Okay, and then my temperature change is always final minus initial, so it's 0 minus a -7. Okay, and your sig figs would be 0.00. So what you're going to do is you're going to multiply it out, and you get 3,470.95 joules. Now what I'm going to deal with is my phase change, which is this flat line. And for phase change, you're going to use the formula Q equals HM. And what phase change is it going through right there? Well, it's going from a solid to a liquid. So we're going to look at that, and we're going to be going from a solid to a liquid, which is melting. And we're going to be using the Q equals HM, as I already stated. And which H are you going to use? Once again, I always try to remember that vaporization, that's easy. That's obviously going from a liquid to gas. That I know. This fusion one, I don't remember as well, but I know it's not vaporization, so I'm going to use the fusion one. So when I look on my constants for that, for water, H is 334 joules per gram, and my mass in this case is 235 grams. So when I multiply that out, I get 78,490 joules. So that's my melting stage. And now what I'm going to try to do is I am going to try to deal with the 0 to 22 degrees. So 0 to 22 is going to be, once again, a warming situation. In this case, instead of a solid, it's going to be a liquid. So this is a warming, and I am going to be going from 0 to 22 degrees. So whenever I'm changing my temperature, I'm going to use that MCAT formula. So my mass, once again, has not changed, so it's 235 grams. My C in this case, because I'm dealing with a liquid, is going to be that 4.18 for water, which is joules per degree Celsius grams. And then my temperature is final minus initial, so 22 minus 0. When you multiply all these numbers out, you get 21,610.6 joules. That should be a J, not a T. All right, so now what do you need to do? Well, you need to add these guys up. You need to add 78,490, 3,470.95, and then 21,610.6. So when you do that, you end up with 103,571.55 joules. I'm going to reference my my problem for my sig figs, and all of them have 3 sig figs, so I'm going to round my answer to the third sig fig. So 1, 2, 3. This is now the number I'm going to round, so that will round up due to the 5 right after, so it would be 104. And then the 571 turns to zeros, so it would be 104,000 joules. In order to answer if it's endo or exo, I'm going to look at my graph. My energy is obviously increasing due to the temperature change. So that would be endothermic because it is absorbing that energy in order to increase the temperature.